Okay, we're going to be talking about the next generation of engineers, Engineering NXG. Because this is like a topic that, thank you, we came up with the title 2 years ago. Like going into schools trying to inspire the next generation of engineers is something that Kabul and I love doing. And to get children interested in STEM and understanding what STEM is. Actually, just to be clear, does everyone here know what STEM is? Okay, if I say a letter, you echo back what it stands for, okay? S? Science. T? Technology. E? Engineering. M? Math. Well done. Right, 10 points for everyone. That was brilliant.
You're missing one. It should be STEAM, and you're missing the A.
A.
Yes. A. Arts.
Arts.
Oh, bonus points. Okay, so throughout this presentation, we're going to go through some of our motivations for what we do, how we do it, and I don't know if you've noticed, but we've set up some equipment. So we're going to have some volunteers come up a bit later. Before we do that, we have our giants are female.
So for this, we decided to go with Anne. She's a Canadian inventor, and she's of a Filipino and Polish heritage, I believe. And she invented the thermoelectric flashlight, so something that can be used where there's no battery or power around. And she was inspired to do this when she had a friend in the Philippines, and her friend failed a test because she couldn't revise the night before because there was no electricity and so on. So she went ahead and won a few awards, attend various awards sessions and so on. I actually didn't come across her in my normal life. If we head over to the next slide, one of the things that I regularly do is run robotics clubs with schools locally. And we did this thing of giving all the students some homework and fill out a form to say what inspired, or find someone who inspires you. And in all honesty, my hero here really is Chloe. She is our next generation of engineers. She's inspired by Anne, and we're doing all we can to be involved in schools to make sure that the engineers of tomorrow know who the engineers of today are or the past are, and they can aspire themselves to be inventors of the future. So that's a little story of how I came across Anne. And who you see on the picture over there is someone I work with, Sandeep. We have regular robotics clubs that we run together, and these days we've got new graduates, another Anne in the audience who's going to be doing bits as well with James. And people like these are role models, and we've got a lot to say about them.
Yeah, so a phrase which I've come across over and over again is, if you can't see it, you can't be it. It's very difficult for children to visualize what they're going to be in the future if they don't have a role model to aspire to be or be like. Now, I've been using this phrase for quite a long time, and it's driven me to go into schools and show what an engineer is, the different types of engineering. But actually, I Googled it to see where this phrase came from, and the extended phrase is, if you can't see it, you can't be it. It's just having those brilliant women break out and do something. Then other girls can say, I can do it too. And this is a quote from Marianne Elliott, who's won every theatre award going. She's won several Tony Awards, for example. Now, I'm not a woman in STEM. I don't identify as such. So how can I be a role model to those children? What's the point in me and most of this room going into schools to try and inspire children? Well, women in engineering, that's part of the issue. There are several subcategories. There's the engineering skills shortage. There's underrepresentation of particular groups within STEM. Now, that's not just women in STEM, certain ethnic minorities. We have issues such as unawareness of neurological conditions, as well as not, especially children, not understanding what an engineer is. Certainly in the UK, people use the term engineer to mean car mechanic, or someone who services your boiler. All great professions, but it does change what people think about what an engineer is. The neurological conditions one, that's a fascinating topic, and I love it. We broadly fit into two categories: neurotypical and neurodivergent. People who are neurotypical tend to have a broad spectrum of cognitive abilities. The ability to learn, remember, socialize, communicate. Those with neurological conditions or so remind me of the word.
Neurodivergent.
Thank you, neurodivergent. Those who are neurodivergent tend to excel massively in an area or group of areas, but find other areas challenging. You know, I grew up dyslexic, I am dyslexic. I've done several talks in schools about what it means to be dyslexic, how you can have dyslexia and still excel in engineering. Now, that's because I had role models myself. My dad's dyslexic, he's an engineer. I had various teachers at school who could recognise my ability in engineering and pushed me down that path. If it wasn't for them, I would still be panicking about trying to read and write and spell. I suck at all of those things. Earlier, when I was saying S, T, E, F, like in my mind, I was like, don't cock it up, please. Make sure I say the letters correctly. Here, on the other side, I'm butchering the pronunciation of the Latin name of a particular toad. And that's a talk I did about learning from nature and how we apply what we find in nature into engineering. This bottom, Kabul, what are you talking about here?
So that was the STEM week, and I decided that I was just going to volunteer to go and talk about STEM to one of the schools. And for whatever reason, I thought it would be quite nice to put a picture up of where I was born and where I grew up. So then I just got them to guess where that might have been. Some interesting answers came back. I still have the recording of it. Someone did think it was Norway, which is quite nice. Beautiful scenery on that and all that. And yeah, so that then transpired to me being more excited about doing more with the students, more with the kids. And just as a thing that if people don't know, I have 4 kids now. The oldest one is 12. And we used to just have a play around, try and get them into engineering and whatnot. So we started this thing with the local school to say, why don't we have a robotics club? And I think in the audience there might be some of you who do these similar sort of things with your kids who are students and their schools. What I found was there was such a want and a drive and a hunger, not just between the students, but in all the teachers, that they don't have the capacity or the time to plan these things. So just a little bit of support that I showed, they chew my hand off, and I was amazed. I didn't charge any money for this. I was kind of volunteering and doing this all as part of my automation thing. Rennishaw has a great STEM ambassador program that's part of the national British or UK STEM ambassador program. But I thought this is something that I'm passionately involved in myself. I want to be more involved, so we set that up. And as a part of that learning, in my personal journey, I found out that there's not just Lego thing that you can do. There's a whole bunch of different things out there, far too many, in fact. And I got very confused at one point about what shall we actually structure this learning for them as. So what we've actually got is a short demonstration of all the little bits of kit that I've come across.
But before we do that, we're in for a treat.
Oh, yes, of course. I forgot about this. So something I also like to do is to take my kids into my work and just show, in the previous picture, what they do to other engineers as well. And then we're going to go into the quiz. Sorry.
Surprise pop quiz. Right. Who here was at my previous GDevCon talk? A couple of you. Okay, you know what's coming. Right, everyone get your phones out. Go to kahoot.it. kahoot.it. Enter the PIN number you see at the top. Danny, Casey, LabVIEW Fairy, awesome. Okay. As you're all registering and getting on screen, I'll just explain what's going to happen. A question will appear on screen. You will have 4 possible answers. You select on your phone which answer you want to give. Okay, we're coming up to about 40. And this quiz basically goes through some of our motivations of why we do what we do. Good, I paid slightly more for a license that allowed me to go over 50, so I'm really pleased we took advantage of that. Okay, I think the code will still remain on the board there, so we all done? 85's good enough. Okay, Engineering NXG. We'll start off with a practice question. It's not worth any points, it's just so you all get used to it. With 95,000 downloads, which is the most downloaded package on VIPM.io? The Arduino Toolkit, DQMH, Digilent, or the JKI State Machine. We've got 5 seconds left. Wow, okay. So this toolkit allows you to interact with things like Raspberry Pi. And this is super, super popular with students. And you know who effectively uses LabVIEW for free through their university? It's students. They use a lot of Pis. I appreciate all of those who chose the JKI State Machine. Yes, I have just moved to JKI. Yeah, DQMH is pretty epic too.
Hey, DQMH won.
It did, yes. Well done, LabVIEW Fairy, for being quickest, but no points. Okay. Right. What percentage of those with engineering degrees work in an engineering occupation? So this is generally speaking, not fresh graduates. 43%, 55%, 76, or 23? Okay, still some of you to submit your answers. 3, 2, 1. Yeah. It's only, all of these figures are UK based. So pitch your country higher or lower than the UK. Be nice. Yeah, so again, we have a massive engineering skills shortage. And it's sort of our own detriment. Engineering is a hugely transferable skill. Well done, Ollie. 71% of boys said they had self-belief in their ability to do well in STEM. What was the percentage for girls?
So that was for 14 to 16-year-olds.
Yes. Yep. This is 2021. Answer, 55, so slightly better than what you thought, which is great, but if you compare this to 71, there's a huge discrepancy, which is surprising because girls outperform boys in almost every STEM qualification. In fact, Kabul mentioned this to me earlier. One of the activities he runs for 6-year-olds, 55% of applicants are girls. Only 45 are boys. Okay, which percentage of engineering teachers have a post-A-level qualification, so just before you go to university? And this question has particular relevance because although all of the teachers are fully qualified to teach the curriculum, it's very difficult to express what an engineer does, what they do, if you don't have that background. Hence, what me and Kabul do. 17.5. But yeah, annoyingly, it's quite difficult to revise for this quiz. Okay, 5 or 6. In 2010, the UK number of women working in STEM was about 500,000. What was the figure in 2021? Okay, 7 seconds. Now, this is some good news. It's a different way of presenting the same statistic. Depending on which report you read, the numbers range from 900,000 up to 1.1 million. It's almost doubled since 2010. I believe that what we're doing with our STEM outreach is working. What we're doing with our Giants Are Female to raise representation matters. It is working. There is progress. And final question. In LabVIEW 2020, which override was added to actor framework? Uninit, disable actor, replace actor, handle first act. Welcome. Where's Alan? There he is. 2, 1. Uninit. You know how we have pre-launch init, where we create various references, open file documents? But if there was an error there, we should create a case structure so we release all of those references. We can now release all of those references in uninit. Uninit will execute regardless of whether there's an error in pre-launch init. The error terminals aren't wired. Cool, let's see who won. In third place, Stefan. Second place, Casey on the LabVIEW Guild. And in first place, oh, this is tense. Whoa! Nice work. Awesome. And with that, I'm going to hand over to Kabul.
Great. So for the next little section, what we're going to do is step through some of the things that I work with the kids in schools. So first of all, we'll have...
Yes, Sarah, come up.
Awesome. So James, if you're okay to come up as well. So what we've got in front of us is... I'll give you the mic.
Sorry, yeah, so this is Lego Spike. It's a fairly new product from Lego. It sort of has a main brain here, which is connected to 2 motors, and a CCD under here, which can detect colour. So the general idea that Sarah will be trying to solve is sorting these coloured blocks by colour into the various containers around.
So it's a colour sorter.
Yeah.
Okay, I'll just point out, Sarah doesn't know what the challenge is. She's finding out at the same time as we're finding out.
So James, what brought you here? Who are you?
I started at Renishaw. I did mechanical engineering and then a 4th year in mechatronics engineering at uni, and then joined Renishaw about a year ago, where I first started using LabVIEW. Since taking my CLD and passed, so...
So when did you first use this?
A couple of months ago, when Kabul gave me this task to design a challenge that somebody would perform on stage. So I hadn't ever seen any of the products before, or the IDE, which you can't see on the screen, but you will see later, which is fairly intuitive, and it is graphical again. It does have the ability to zoom, so not quite LabVIEW.
Cool, and you've got a challenge for Sarah, who we all know already. So, go ahead.
So, yeah, if you are.
Take a seat first, I suppose. So, you have your blocks?
Yeah.
Yeah, awesome, they're all lined up.
So the general sort of layout of the IDE is that you've got a start program here, and then on the left you've got your blocks, which you can drag onto the screen. If we first connect, if we turn it on first, so we just press and hold, and it comes on, and it will give us a little tune, which you might not be able to hear. And then if we connect in the top left, you can connect with it. It's your initial here. Over Bluetooth. You can also USB it in. And then if we just close that once the... Yeah. So yeah, on the left you've got your various blocks that you can use, and we can see on the top left of the screen the various motors and the colour camera that can be seen. So if we drag some blocks onto the block diagram,
So that is
generally building, from there, which I think Sarah is going to do.
awesome.
No.
So while Sarah does that, we're going to bring more people onto the stage. So your challenge is, quite simply put, to try and see if you can find a way to program it to sort the colour bricks out. And we'll take the mic off of your hands for a sec while you advise her on how to get that.
And now we have a couple more voluntolders who are now looking much more scared than they were. Welcome stage. Jürgen, do you want to come up? As well as Anne?
Yeah. If you grab a chair. So next we've got a Lego WeDo kit, and this is more used for our junior engineers from age group up to about 9 years old, so there's a prime 9-year-old. And for this particular, so this particular one, that's what it kind of looks like down there. Anne's going to tell us what it's all about.
Yeah. Can I get the... Yeah. Hi, I'm Anne. I've brought with me a little Lego WeDo 2 kit. And this is a little Milo rover. It's very simple. It's got a motor controller, and it's got a little proximity sensor over here, and it just can move forwards and backwards and sense stuff around it. And this is the sort of thing we brought to the primary school with Kabul. And it's amazing to see what primary school children can actually do with these things and get out of these things. So it's really cool to see. So yeah, we've already connected this up. And what we do, we just start the project. And it starts very easily. Can we see that? Yeah. With a start button, and we've got some blocks we can drag in similarly to here, but just a bit more simpler. We have motor control blocks, some images and sound blocks. We can even send some messages, almost like queuing stuff and waiting for stuff to happen. And we have some sensor symbols, so it's waiting for the sensors to pick something up. And yeah, that's basically the gist of it. So if you basically want to try and first make it move, and then pick up whether it can find this little tulip, Lego tulip. And that's what it is.
Cool.
Your
So
challenge.
Awesome. So the objective is to drive past it and stop and count how many times you see the tulip.
Yeah.
So you've got a motor, you've got a sensor for proximity. Sounds pretty simple, right? Alright, we'll see how you get on. We'll come back to you in a bit as well, while Sarah's getting along over there. So, next.
And lastly, Brian, do you want to come up?
So next we have something that I'm trying to get my 2-year-old to try and do. So here's a little kit. It's called OSMO. Again, I'm not selling any of this. It's just stuff that I've used, and if it's useful, it's great. And it works with an iPad. If we can see on top over here, the iPad's got a little mirror mechanism on here, so it basically then allows you to see whatever's in front of you. So it comes with a few different apps. We've got one over here, and you've got a few different blocks. And hopefully you can make out in the video stream up there. Yeah, you sort of can. There are various different blocks, which is almost graphical coding, but physical. And I'm sure some of you might have come across this before, but the pretext of it is make something by simply putting it in front of it. So if you put it there, it'll sort of recognize it, and you execute it by just simply tapping the screen. So it'll show you if you put it pointed upwards, it'll show you that it's going to go upwards. So what you can see there is if we change the view a little bit, so that's what we see on screen right now. And if we kind of change the layout over there, it'll do that. Hopefully that makes sense? Cool. So we'll let you proceed with that. Let's see, we'll follow you as you go along and see how you get along. See what blocks you have as well. And we'll monitor your voice as well at this time. Does this work? Talk to us while you do it. So that's a simple one, isn't it? You just want to. That's it. Tap the screen there. So. Ah, cool. That is. So yes. So that's pointing upwards at the moment.
Oh, it's telling me what to do.
Yeah. There you go.
It's basically Hello World. Nice.
Indeed.
I'm good at this.
So how's this for graphical coding, eh? Good. But it's single steps. We've got to build up to something more. Do you think you could make him do a bit more? Awesome. There we go. Yeah, absolutely. Running against a tree, banging his head.
Oh.
So the idea here is, again, if you're young, you're just trying to get used to what programming is, what an algorithm is, you know, you don't have to wait for a teacher to teach them at school what all these things are. In its basics, algorithm is just a list of steps that you're going to make something do. That's what's taught to these kids, you know, when they're 4 or 5 years old these days. And what you're doing here is a simple algorithm that you're creating again and again. I don't know if you guys have any floors with squares in it. I used to take my kids swimming lessons quite a few times, and we used to have that pattern on the floor, and that's something that we used to do. I used to close my eyes and make my child tell me where to go, and I'll bang against the tree, not quite the tree in a swimming pool area, but you get the idea. So, you get the idea. Do you like it? Cool. Do you want to carry on going, or? we'll leave you for now. We'll see how it goes. So while that's going on, and let's see if you can actually progress through to something that shows as an objective. So you're supposed to collect fruit, I think, at one point. So we'll look at how Anne is getting along over here. Cool. Do we have some sort of a solution?
So
I don't know if you've realized, this is like a cooking show. We're just going backwards and forwards in a little bit of a chaotic situation.
yeah, so what we've got so far is we've got it to sense it and stop when it senses the tulip, and it moves a bit backwards again. So now, yeah.
We're discussing which color it should shoot. But no, it's
Ah, I see. Which color? Nice. Good. You've obviously worked with LabVIEW.
yes.
How do you find this interface?
Oh, it's nice. It's not as good as LabVIEW, I would say, but it has some strong suits.
Sorry, how old are you again? A 10, awesome, that's great. And did you have anything else to show on this?
I thought what was really interesting about this was you could actually still send, like, when it completes a row, for example, we were going to get onto this, it could send a message and say, and have a new row of coding blocks, and then it only starts that row once it gets that message. So it's a bit of like a
Cute.
cute.
Nice.
I was wondering where the while loop is, so you can go back to the start in a way if you repeat it. Is this the while loop?
Yes.
Try it.
Oh, I will.
Nice. Cool. So that's good. Thank you very much. You happy with that? Awesome. I'm not, again, looking to get any... What's it called again? Where you get money for you selling bits? That's the one. So we'll then hop along to the other one and see how Sarah's getting along. Hopefully we can see some of that. How are you doing,
I
Sarah?
don't even know what that would like.
Getting there, I think.
Yeah? What have you got?
I reckon so.
This is kind of like a live code review now, packing it all in.
See what I'm doing. Feel free to give me hints.
What have you got so far? That looks like a pretty decent...
So my motor was going the wrong way. But,
Okay, so you're almost sorting it, it's pushing it. Maybe some just parameters now. That's some deep thought. Cool. So I think we're sort of coming close to our time as well, so how about we review something that you've got before, something we've cooked before?
So yeah, we were really close here. I was purposely not giving Sarah that much help, just because I'm mean. If we just reset it. Hardware, just hardware. Yeah, so if we run what I've run previously, so there is, if we, I've lost the mouse, there. Yeah, so that's Sarah's layout, which we've got going through, looking for a block colour and then going to various position. I did it very similarly, oh, wrong one, no, right one, where we just set the motor speeds and everything at the start, and then I've just got essentially a while loop, and then it checks the colour, goes to, well, sets a variable and then goes to a position.
Can we see it running?
Yep.
Awesome.
Hopefully that's the right code. What do they say about technology?
And live demo. We'll just check out what you're getting up to as well while that's all been going on. Looks like you've... oh, that was close falling off the table.
Nice, amazing, thank you. Okay, so those were 3 demonstrations of the type of thing you can do when you with your own kids or going into schools to try and inspire them into graphical programming like this. I prefer just to do presentations. I go into schools and do assemblies. I find it much less stressful than all of that. But yeah, that's basically everything we had. We're on LinkedIn. We both have YouTube channels, Tom's LabVIEW Adventure and Automation.
Yep.
Perfect. We're both on Twitter. You can twatter us. We're on the NI community.
And the only other
Nice.
thing is,
Go on.
I'm not on TikTok, but my kids are, and if you follow cat videos like Alan. Then he's got 2,000 odd followers, apparently. I don't know what TikTok is.
Happy days. All right, thank you.
Awesome. Any questions before we can't shoot off?
First of all, thanks for a great show. And of course, there's right now abundance of those toys. We see them everywhere popping up. The question is, first of all, well, how to choose the best ones? Are there some places where they can review them or having good ideas which ones are the best at the moment? But also, not only the best toys are important, but also the programs and plans. Is there an association or is there a place to find those inspirations, how parents can assist their kids and their friends around?
Absolutely. So I don't know, well, most of the parents I spoke to were not really aware of IET in the UK, so the Institute of Engineering and Technology, and they have got something called the Lego First League, and effectively you can start from that. We've got kids starting from 4 years old, so not these things, but there's discovery is what the first level is, and they've got lectures. Effectively, you can go through them, and they've got set lesson plans and everything else that takes you through the whole of the Lego suite. Now, it's not just Lego, obviously, there's other manufacturers as well, and they all have their own platforms. I think Meccano have one, there's various other ones. I personally found that the IET thing worked quite well for me because I'm an engineer. Other parents, and that's kind of how I landed on this. I didn't find this because Apple. And other parents kind of suggest, oh, have you tried this one? I bought it, I saw it, I fell in love with it. You know, especially when you're starting off, that can be a little bit daunting when you're a little bit younger, so this was just ideal. So there are lots of resources. Who you are kind of dictates where you look, and maybe there's a little market for you writing some blogs, maybe how your journey is if you're going through that route. I haven't written any yet.
Thank you.